Hey you guys, it's geometry time. We are in chapter 11, section 4, and we are now talking about volumes. We're looking at the volume of a rectangular prism, the volume of a triangular prism, the volume of a cylinder, and how to find the volume of a composite figure. So let's get started. Alright, so let's start out with some vocab. In the previous sections, we talked about area. We had lateral area, we had surface area. Now we're going to be talking about volume. And volume is the space that a figure occupies. In this picture below, we see that the area of each shaded figure, each shaded cross-section, is 6 centimeters squared. Now, if two space figures have the same height and the same cross-sectional area at every level, then they have the same volume. This idea here is called Cavalieri's principle. Now we can extend this principle to pretty much any prism, and that's how we can come up with the volume of a prism. So the volume of a prism is the product of the area of the base and the height of the prism. So volume is equal to base times height. Again though, the base is the area of the base and then the height of the prism. Alright, so let's try some problems now. So finding the volume of a rectangular prism. Step 1, we're just going to write the volume or the formula for volume. So volume is equal to area of the base times the height of the prism. Well, in the shape that we have in this example, we can decide on pretty much any of these different sides, front, back, or top, and bottom, or right and left as our base. I'm just going to go with a typical top and bottom though. So my base, I'm going to say, is this 24 by 20. So area there, we're going to have volume is equal to 24 times 20. And then times my height, well if 24 and 20 is my base, then from base, bottom base, to top base, the height refers to your altitude. My altitude here is 10. So times 10. So I just did step 2 and step 3. Step 2 was determine the area of the base. Well, that's whatever 24 times 20 is. And substitute base and height values into formula. So I just did that. So my last step is to calculate. So volume is equal to 24 times 20 is 480, and that times 10 is 4,800. And my units here are going to be centimeters cubed. So before we always said squared. Square was for area. For volume, it's going to be cube. So here's my final answer. Alright, you guys, you try. Let's look at this problem below. Alright, so now we're going to find the volume of a triangular prism. The last problem, we looked at a rectangular prism. Now we're looking at a triangular prism. The only difference here is our base. So notice in my example, my base are these triangles here. The left triangle and the right triangle. I know that's my base because I only have 2 of them. So volume, step 1, volume is equal to base times height. And let me go ahead and change that color so we can see it a little bit clearer. Volume is equal to base times height. Now the base is a triangle, and area of a triangle is going to be 1/2 base times height. Don't confuse this base and height for the base, and I should capitalize that B. For the base and the height for volume. The base for volume stands for area of the base. And the area of the base is found by taking the base of that triangle and timesing it by the height of that triangle. So again, let's not be confused there. Notice we don't have any 90-degree angles letting us know that this side and this side create a right angle, nor this side or this side. So we're going to have to determine the height of this triangle. Now we can't forget our other h in this problem, the height of the prism itself, and that height is easily found by looking at the diagram. From this triangle to this triangle, 10 inches is our height. So to find the height of the triangle, I'm going to draw out that triangle. We can see that all the sides, 8, 8, and then this side of this triangle is going to be 8 because it's congruent to this side. So we have an equilateral triangle. So 8, 8, and 8. So for me to find the height, well, I could drop my altitude here. That's perpendicular. And I know that all my angles are 60 degrees. So that's 60 degrees here. So what I really have is a special right triangle. I have a 30, 60, 90 triangle. If this hypotenuse is 8, then this is my short side down here, and that's going to be half of 8, which is 4, which makes sense. Both of these are 4 right here. So the side that's across from the 60, my height, that's my long side. And my long side, if you look at your special right triangles, is always your short side times the square root of 3. So my height is 4 radical 3. So I'm just going to plug this in. So volume is equal to 1/2 times 4 radical 3 times the height. I'm sorry, I wrote that in the wrong spot. Oops. B is my base. My base is 8, base of my triangle. Height of my triangle is 4 radical 3. And then height of my prism on the outside is 10. So this 1/2 came from here. The base of the triangle is 8. The height of the triangle we just determined was 4 square roots of 3. And then the height of the prism itself is 10, because that connects the triangle to the triangle, the base to the base. So you just plug all that in, and now we just calculate. Our last step, plug this in and calculate. So your volume is equal to 277.128129. So we're going to round that and say it's approximately 277 inches cubed. Alright, so now it's your turn. Try the same thing. This one isn't going to be as difficult because if you check this out, we have already the base and the height of your base, your triangular base. So it should be a little less complicated. Alright, so now we're going to find the volume of a cylinder. To find the volume of a cylinder, you're going to use the same formula that you use to find the volume of a prism. However, though, B is the area of the circle. So the volume of a cylinder is the product of the area of the base and the height of the cylinder. So volume equals base times height, just like before, where base stands for area of base. But since our base is a circle, area of a circle is pi r squared. So we really have pi r squared times h. Alright, so let's find the volume of the cylinder in terms of pi. So we want to leave our answer in terms of pi here. Well, remember volume, right, the formula for it, is base times height. And in our case we have a circle, so the area of a circle is pi r squared times the height of the cylinder. So plugging in what we know. Well, we'll leave the pi there. Our radius is given to us. We see our radius is 3, so 3 squared. And then the height, again, the height is the length of the altitude that goes from base to base, so 8 is going to be our height. So now we just calculate. We have pi, 3 squared is 9, and then 9 times 8, we get 72 pi. Don't forget to write your units. Our units here, oops, looked all funny. Our units here are going to be centimeters, and since it's volume, volume's always cubed. So here's our answer. Alright, so you try. Check this one out below. It's a little slanted cylinder down here, but go about it exactly the same way. Oh, and this line, it looks like the diameter here is 2, so go ahead and go with that. The last thing we're going to find the volume for is a composite space figure. Now, a composite space figure is a three-dimensional figure that is the combination of two or more simpler figures. You can find the volume of a composite space figure by adding the volumes of the figures that are combined. So that makes sense. We're just going to find, just like before when we had some kind of irregular shape and we wanted to find the area for it, we would break it up into shapes that we knew and we would find the areas separately and then add them up. So we'll do the same thing. We'll find the volumes of shapes that we know separately and then add them together. So in our example here, we want to find the approximate volume of the bullnose aquarium to the nearest cubic inch. Don't let this cubic inch throw you. It's just letting us know that our answer will be inches cubed. Alright, so let's break this apart. We see that this aquarium is a combination of this rectangular prism here and half of a cylinder. So we're going to find the volume of each figure. So if I actually try to cut this and make it look like my rectangular prism over here and then my half a cylinder over here, we'll notice that this length is 24 inches. So that makes this length right here 24 inches also. And notice that's your diameter. So if 24 is your diameter, then you know from here to here is your radius. And your radius is half your diameter, so that's just 12. So from here to here, I know that's 12. So then the length here is 48 minus 12, which is 36. So let's break this up into two different volumes. Let's talk about volume 1, and that's going to represent our rectangular prism. And then volume 2, we'll let that represent our cylinder. So for our rectangular prism, we know volume is equal to area of the base times the height of the prism. So substituting in my values here, the area of the base can be found by saying 24 times 36, and then the height of the prism is going to be 24. And when I multiply those all together, 24 times 36 times 24, my volume of this rectangular prism is 20,736. I'm going to add to this the volume of my cylinder. So let's go and find the volume of your cylinder. Now I'll erase that right there. So we can add. Now volume of the cylinder is the area of the base, which is pi r squared, times the height of the prism. And we only want half of this. So I'm going to multiply the whole thing by 1/2. Now plugging in what we know, volume is equal to pi. My radius we said was 12, so 12 squared, times the height of the prism, 24. And we're taking 1/2 of that. And so if you just plug that into your calculator, pi times 12 squared times 24 times 1/2 gives you 5,429. Adding those two together, we get 26,165 inches cubed. And this is our final answer. Alright, so your last problem, check it out down below. I want you to find the approximate volume of the lunchbox shown at the right. Round to the nearest cubic inch. So round to the nearest whole number. Alright you guys, hope you had fun. I'll see you tomorrow.